I'm Suleiman Lapalm,
And I'm James Ellers.
and we're Team Screw Interference. The problem we'd like to address today is during orthopedic surgery, a cancellous bone screw may be over-torqued and lose bone purchase. The solution we have in mind would be to remove the stripped screw, place a interference device into the hole, and replace the screw, immediately regaining screw purchase. It's hard to know exactly how often screws lose purchase during orthopedic surgeries, but in my experience and with discussion with orthopedic surgeons, I know it's more frequently than once in 100 and less frequently than 1 in 10. Cancellous screws are used very frequently in orthopedic surgery. They're seen in trauma surgeries, in joint replacement surgeries, and for pedicle screws in spine surgery. Currently, the remedies for if you lose purchase would be to leave the screw in place and simply put in another screw. You could try to redirect your trajectory. You could remove the screw and inject methyl methacrylate, a bone glue, or you could remove the screw and insert a larger screw. There are some shortcomings to this. Some screw locations are critical and may not tolerate a larger screw or a different trajectory. And injecting methyl methacrylate can be slow. You have to wait for the glue to be mixed and set. Additionally, it can be a nidus for infection. It is never absorbed into the body. And if the glue extravasates out of your screw hole, it can cause damage to adjacent tissues, especially neuro tissues.
So what we propose is to mill a piece of bone, a cortical bone, out of a cadaver into a shape much like a matchstick so that you can remove the original screw, insert the device, and then reinsert the same screw into the same hole. We have two different ways that we want to do this. The first one is just a simple rectangle, much like the existing matchstick. And the second one is a little bit more complicated. And on the left-hand side, there are little tines that will interact with the tines on the screw. And on the other side, there are jagged edges, which will interact with the outside of the hole in the bone, providing additional friction for pull-out. The value of a device like this is that it is immediately effective. Unlike the glue, this device will be absorbable into the body and is immediately useful, and will not have to wait to be hardened, much like the glue. It's also less expensive than purchasing an additional screw and will allow for the original trajectory to be used. So far, we have practiced this on a porcine bone model, and we are in communication with the University of Utah and their biomechanics testing facility to provide a screw pull-out force study.
Thank you.